more more modifications, more translations, more different stuff. The next thing is we're going to throw another constant in here. Hey, Thomas. Getting some enthusiasm from the cats. Thank you very much. Have no fear. The water is well away from the computer. No more disasters planned. In any event, so y equals a times the sine of b times x. So our new variable here is value b. Value b is going to affect the length of the cycle. The cycle length. So b affects the cycle length, which is our period. So the standard period, right, is 2 pi. So the new period is going to be 2 pi divided by whatever b is. And so what's going to happen here in general if we see something written like this with a value b, we're going to sort of think of it kind of by default as a positive whole number, but in theory b could be a fraction. They'll be positive. I don't think we're going to mess with negatives too much. B could be a fraction, in which case when we divide, slightly different things will happen. But the short version is this is going to affect our cycle length. And then that sort of in turn is going to affect a little bit where our key points live. So if we're changing how long the cycle is, if it's not just 0 to 2 pi, then that means our sort of halfway points and our quarter points, right, those quadrant points, are not going to fall on 0 and pi over 2 and pi and 3 pi over 2 and 2 pi. Those are going to change also. So our 5 key points will sort of run from x1 equals 0 to x5 is whatever 2 pi over b is. And then our sort of distance between them, between all the points, is going to be whatever this period length is, divided by 4, right? So we're taking the whole cycle, one length p, and dividing it into quarters. This is hopefully kind of intuitive. It's just good to have it sort of laid out. As always, let's sort of run an example to try to learn this. We're not going to put an a on first. Let's sort of just do this cycle length change. So let's say y is the sine of, let's do 4 times x. I'll switch our colors here. So the effect here is our b value is 4. And so what that means now is our cycle length is going to be 2 pi divided by 4, which means pi over 2. So what's happening is if I sort of multiply 4 times the x, it's essentially quadrupling how fast we cycle through the behavior. We're sort of speeding up the frequency, right, of how often these waves are going to go by. So if it's times 4, it sort of speeds up how often they come through, which means the cycle then is actually sort of cut down by 4. And so now the full cycle goes from 0 to pi over 2 instead of going from 0 all the way out to 2 pi. So what we need then are sort of x values. So x0 is 0. I'm sorry, x1 is 0. x2, our second point. So what we're going to do is we're going to do 0 plus the period over 4. So what the heck is p over 4? Well, the p value is pi over 2. So p over 4 would be pi over 2 divided by 4. That's going to look like pi over 8 for us, right? This is in theory, we squeeze this in, pi over 2 times, if I flip this, 1 over 4 would get me pi over 8. You can also think of this, right, if this is in some sense 1/2, right, pi over 2, and then I'm breaking that down into quarters, what would 1/4 of 1/2 be? Well, it would break down to 1/8. So this becomes underneath, right? So this is 0 plus pi over 8. So that means my sort of x2 value is going to be pi over 8. x3, I'm just going to take the previous one, right? And then we'll add again. So that would be 2 pi over 8 would be pi over 4. This is not quite as organized as I would like, but I'll live. Pi over 4 plus another pi over 8. This is going to end up being right. This is like 2 over 8 plus 1 over 8, so that's going to be 3 pi over 8. And then we kind of know by default x5 should get us back to pi over 2, and it will if we do, right? 3 over 8 plus 1 over 8, that's going to be 4 over 8, would be pi over 2. So this aspect is a little bit messier. We're definitely sort of working with fractions here. It just kind of is what it is. Honestly, you know, I'd love to tell you like it's not that bad, but it's definitely a little bit awkward. I mean, it's not that bad, but it could be better. If we start to make our table, a couple things here, right? My a value is just 1, right? I didn't put any sort of other value in front of the graph. So my amplitude is just positive 1. So my like max min is just positive negative 1, and it's going to happen in the usual order: the middle and then the max, the middle and then the minimum, and then back to the middle. So let's put all this stuff together. X and Y. So what are we working with? So 0. Where is it? The next one is going to be pi over 8. Our next point, right? 3 was pi over 4. Fourth one's going to be 3 over 8. And then this last guy was pi over 2. And then our values here, this is still just going to be middle, max, middle, minimum, middle. So that's going to be 0 up to 1, 0 down to minus 1, and then hitting 0. So what I'm really doing here is I'm going to affect my sort of x axis. It's going to affect the labeling there. Let's draw it. Best we can. You probably noticed that when I'm drawing it, usually what I do is I sort of mark a half point for the cycle and then the end point. So this is going to go out to pi over 2. This halfway point was pi over 4, right? And then I'll do quarter and quarter. So that's pi over 8. And that's 3 over 8. My 0 is here. We'll do max min, negative 1 and 1. And then we'll kind of eyeball a couple more values as if we would keep going. So we'll mark it. Starts at the middle, up to the max, to the middle, down to the minimum, and then up to the middle again. Same kind of curve, and then we'd continue, right? Do my cycle. Like so. So that's going to be y equals the sine of 4x.